In this video, you will learn about the order of real numbers. And what we're doing basically is we are just comparing different numbers. So looking at, if a number is bigger than another number, or smaller, or equal to. So that is the objective of this lesson. Now we are doing this in the context of algebra, which will require some math notation. So we need to know how to convert different things into math notation. For example, if we said -2 is less than 4, okay, that's an obvious statement, but in math notation, the symbol for less than would be right here. All right, so this is our symbol for less than. -2 is less than 4. All right, and then if we said 4 is greater than -2, so using the same numbers, but just turning it around, we would write this like this, where we have 4 is greater than -2. So this symbol right here, that is your less than symbol, and then that other symbol right there is greater than. And if you forget which one is which, notice the less than symbol looks kind of like an L, right? So it's kind of like an L. So L for less than. All right, and notice too that if you imagine this as a mouth, so you can draw a little face if you wanted, draw a little Pac-Man or whatever, the mouth will always be facing the larger number. All right, so notice here the 4 is bigger and the mouth is facing the 4. Over here, the 4 is still bigger and the mouth is again facing the 4. So when you write this, make sure that it is opening in the correct direction. Okay, so using that math notation, you have to determine if the following are true or false. So is this true or false? Well, this would be true because this says 0 is less than 8. That is a true statement. And notice the mouth is facing the bigger number, which is the 8. So once again, this would be true. Now what about this one? Well, this says 4 is greater than 3, which is a true statement, so that is true. And if you're just looking at the direction that the mouth is facing, it is facing or open towards the 4, which is bigger than 3, so this would be a true statement. Next we have -1 is less than 3. This is also a true statement because -1 is smaller than 3. This one, we have -2 is greater than 8. That is not a true statement, so that will be false because -2 is not bigger than 8. Next we have -5 is less than -1. Okay, this is a true statement because -5 is smaller, so that is true. Next we have -3 is less than -4. Okay, this is false because -3 is not smaller than -4, so that is a false statement. And lastly, we have 1/3 is less than 1/2. This is a true statement because 1/3 is smaller than 1/2. So in addition to less than or greater than signs, we also have other ways to compare different numbers. And by the way, these symbols are all called inequalities. So because it's not equal to, all right, it's greater than or less than. So an inequality is something where it's greater or less than, but there's also other forms of inequalities. Another one is x is greater than or equal to 3. This phrase right here, greater than or equal to, in math notation would have a greater than sign combined with an equal sign. So we take half of the equal sign, so we see one line here, and then we put that with the greater than sign. So this says x is greater than or equal to 3. Now what this means is that x is either greater than 3 or x is equal to 3. All right, so for example, if I said my age is greater than or equal to 27, that means my age is either equal to 27 or greater than 27. Okay, here's another phrase, x is less than or equal to 3. So in math notation, we would use the less than symbol, but then we would also combine that with the equal sign. So we just take half of the equal sign, and it would look like that. So my math notation would be x, and then this symbol, and then 3. And what this means is that x is less than 3, or x is equal to 3. And again, using the similar comparison as we use for the greater than or equal to, if I said my age is less than or equal to 30, that means my age is either less than 30 or it's equal to 30. All right, so that's what this phrase means. One more inequality that we could have is not equal to. The math notation for this is we take an equal sign, then put a line through it, which means not equal. So for example, 4 is not equal to 7. Okay, let's work a little more with this different notation. Here, if I want to say x is between 7 and 12. Okay, there's different ways I can think through this. Okay, if it's between 7 and 12, that means x has to be greater than 7, and x needs to be smaller than 12. Okay, that is one way I can think through that. All right, but it's better and maybe more simple if I can write this all at one time. So instead of writing this out with all of these letters and numbers, it'd be better if I can write this in one quick math notation. So what I can do is I can imagine switching the x and the 7. So instead of x is greater than 7, I have 7 is less than x. That is true because I just switch the side and I change the way that the inequality is facing. Right? Notice the mouth is still facing the x no matter which way I have this. So that is a true statement. Okay, and x is less than 12. So if I write this all together in one expression, I'd have 7 is less than x, and x is less than 12. I can combine and have so x is less than 12. So right here 7 is less than x, and here is the part x is less than 12. Put it all together, and that is my expression. Now, you don't want to go through this entire process every time to try to determine how I set this up. So bottom line, what I'm doing is I take 7 and 12, so 7 and 12, and put x between them. So just write it with x literally in between the 7 and 12, and keep both the signs as less than. All right, so that is the best way to write this expression. And technically speaking, if I wanted to, I could change the order. So if I wanted, I could put 12 over here, and x in the middle, and then 7 over here. Just make sure the inequality is facing the right direction. So notice the mouth is facing the 12, so keep it facing the 12 over here, and the mouth is facing the x for this part, facing away from the 7. So write it like that over here as well. So I could write this as 12 is greater than x is greater than 7, but the better and more standard way of writing is with less than signs. Next, we're going to get a little practice with using that notation. So we have some true or false questions. Here we have this statement, and you're to determine if this is true or false. Well, the quickest way to determine is just simply look at the numbers we have. So it says basically 0 is between -3 and 4. So on the number line, is 0 between -3 and 4? Well, yes, 0 is between 3, or -3, and +4. So that is a true statement. Next we have this statement, -3 less than 6, less than 4. So we see 6 written between -3 and 4. So the question is 6 on the number line between -3 and 4? Well, it's not. 6 is bigger than 4. So because of that, this is a false statement. Okay, next we have 5 is greater than or equal to 8. For this statement to be true, we compare or look at the two statements we have built into one, right? We have 5 is greater than 8, and then we have or 5 is equal to 8. That is what greater than or equal to says. Well, both of which are not true, so therefore that is a false statement. Next we have 5 is greater than or equal to 5. So that says 5 is greater than 5 or 5 is equal to 5. For this to be true, one part of these needs to be true. 5 is not bigger than 5, but it is equal to 5. Right? So because one part is true, the entire statement is also true. Right? And that's with any or statement. Okay, with any or statement, as long as one part is true, the entire thing is true. Next, if I had 5 is less than or equal to 5, that means 5 is less than 5, or 5 is equal to 5. Well, 5 is not less than 5, but it is equal to 5. So therefore, it is true. Now, what about this statement? Well, this would be a true statement because 4 is not equal to 5. So this would be true. Now, we've mentioned this previously, but we have this term called inequality. And here we formally introduce it, where our definition is a statement that is not equal. So in, that prefix means not. So this means not equal, right? Not equal. So examples we've already seen before, but we have like -4 is less than 2. We could have like statements with variables in here. So 2x plus 3 is greater than or equal to 7. Could be something like this, or like this, or like that. All of these would be examples of inequalities, where we have all these different inequality symbols. So some things that are not examples would be anything with an equal sign. It's like 3 equals 3, x equals 4, x plus 3 is 2, y equals 2x minus 4. Anything with an equal sign is not an inequality. So we've worked with inequalities with just numbers and comparing different numbers together. Now here to finish off, we will now combine algebra with inequalities. So here we need to find the solution set of this inequality. So we have x plus 4 is greater than or equal to 5. And we are finding the solution set if x is an element of -2, -1, 0, 1, or 2. What that means is that x has to be, or x could be, any of these numbers. So x cannot be any other number other than these 5. So what I do is I plug in these 5 numbers to determine which of these, if any, are a solution to the inequality. So for example, -2, we plug that in for x. So we get -2 plus 4 is greater than or equal to 5. So the question is this a true statement? Well, -2 plus 4 is 2, which is not bigger than 5 or equal to 5. So this would be false. All right, so -2 does not work. What about -1? So we plug a -1 in. We have -1 plus 4, which would give me 3. Is 3 greater than or equal to 5? Well, no, so that is false. So -1 does not work. All right, now what about 0? So plug a 0 in for x. We get 0 plus 4 is greater than or equal to 5, which is also false because 4 is not greater than 5 or it's not equal to 5. So that is a false statement. So 0 is not a solution. We plug a 1 in. We have 1 plus 4, which is 5. So is 5 greater than or equal to 5? So 5 greater than or equal to 5. So that would be true because with this statement, we have stated either 5 is greater than 5 or 5 is equal to 5. So the first part is not true, but the second part is, which makes the entire thing true. So that is a true statement, which means 1 is a solution. And lastly, we plug a 2 in. We have 2 plus 4. So we have 6 is greater than or equal to 5. That is a true statement. So therefore, 2 is also a solution. So my solution set would be 1 and 2 because those are my answers that give me a true statement. So my solution set is 1 or 2. And to finish off, if we wanted to graph the inequality, the graph of this, we only have 2 answers. It's either 1 or 2. All right, so on the graph, all we do is we plot the points 1 and 2. So put a point here at 1 and a point here at 2 because that's the only two answers based off my set up here. All right, so that is my solution. Now to finish off, we also want to know how to graph inequalities in general. So what if you were told to graph y is greater than -2? Well, what I'm doing is I'm taking a number line and I'm shading in all the possible solutions. So anything that would make this a true statement. So what numbers are greater than -2? Well, we have -1, we have 0, 1, 2. Anything over here on this right side is bigger than -2. So what I do is I shade in everything on this right side of -2, because that's bigger than -2. And notice it is not equal to -2. All right, it's just bigger than. So -2 is not an answer. So I do not shade in -2. What I do is I put a circle around it to show that, hey, I'm not shading it in, but my answer could be really close to this. All right, because we could have a -1.99999 that is still bigger than -2. So put a little open circle around it to signify that it gets infinitely close to -2, but never actually equals -2. All right, now what if you had y is greater than or equal to -2? So it's really the same kind of setup where we're shading in everything bigger than -2. So everything over here. But this equal sign, as part of my inequality, that means it also could equal -2. And because it's equal, that means I shade it in as well. So I shade in -2 with a closed circle. All right, that's because it's equal to, right, this equal part. So because it's equal, we shade that part in. Now what if we had the opposite sign, so like y is less than -2? Well, it's really the same idea, but here we're shading in the numbers that are smaller than -2, which the numbers that are smaller are here to the left. -3, -4, -5, those are all smaller than -2. And again, notice that y is not equal to -2, y is just smaller than -2. So what that means is that I cannot shade in -2. So I need to put an open circle around -2 to show that I'm not actually shading in -2. I'm just getting infinitely close to it, but never actually equaling it. Now, if you had a less than or equal to sign, then we would shade into the left because it's less than, right? The numbers that are smaller than -2 are to the left. And here we have the equal sign, which means it could equal -2, which means I do need to shade in the -2. So I shade it in with a closed circle. Okay, a few more examples. What if we had 3 is greater than or equal to k? This one you got to be careful with because the k is on the right side here. And what we're shading in is we're shading in what are possible answers for k. So it's helpful if I actually rearrange this and put the k on the left side and the 3 on the right side. Make sure the mouth is still facing the same direction. So it was facing the 3 initially, so it needs to face 3 here as well. So if 3 is bigger than k, then k is smaller than 3. All right, so at this point, we can graph quickly. On the number line, less than would be shading in to the left with the numbers that are smaller than 3. So you shade into the left of 3. And it's equal to, it could be equal to. So I put a closed circle on 3 because it could equal 3. And then I shade in everything to the left. Now if I had x is not equal to 3, what that means is that x can be anything except for 3. So x can be bigger than 3, x could be smaller than 3. The only thing is x cannot equal 3, so I put a circle, an open circle here at 3, not shaded in, because x will not equal 3. All right, so this would be the graph of x is not equal to 3. And last one right here, if we had this statement, we were told to graph 2 is less than or equal to x is less than 4. Okay, the graph for this is pretty quick because I'm literally shading in between 2 and 4. So just how you see it written, x is between 2 and 4. When I shade in, I'm going to shade in between 2 and 4. And just be aware of the signs, that this less than or equal to sign is going to be a closed circle, and the less than sign is going to be an open circle. So when I graph, it has a closed circle here at 2 and an open circle here at 4. And that concludes our lesson for today. We will see you next time.